All right, so I'm going to show you a nifty way to do your truss analysis. So bring up Inventor, pull up a part. All right, and you're going to do a 2D sketch. All right, and you can put it on any plane. I picked that one. Okay. And then we're going to do a very simple sketch. So we're going to do a stylized truss here. I'm just going to lay it out very quickly. Now this is the case you would design your own truss. And I'll put a top on it. And then to keep everything nice and easy, we're going to say all the members are the same length. And we can say this is 2 inches. Again, whatever you have for your truss. That looks small. Let's make it 2.5. Why not? All right, finish your sketch. And you're gonna have to save it. All right, so we'll save it. I'll overwrite this 3rd hour truss that I did with 3rd hour. Yeah, I'll replace it. All right, and now this is the part where you're probably going to be confused. We have to go back and make an assembly. Okay, so trust me, just make that part, save it, make an assembly, place that part. So 3rd hour truss, place that part into the assembly. You just need one of them. Okay. Save the assembly. So I'm going to call that. I'm going to overwrite the assembly 3rd hour. You replace it. Yes. Okay, so now we have that part with the drawing and the assembly. Okay, so we're going to go over here to design, and we're going to do insert frame. And the frames are really cool. They will take a sketch. This is your framework, all right, and then they will make whatever you want to lay out into it as a 3D part. Okay, so say we go here to you know, if I want these to be made out of hexagons, right? So it will take this member and turn it into a hexagonal shaped member or an I-beam shaped member. Okay, so what you're going to want to set is we want square rectangular hex. I'm going to go into ANSI. I want ANSI rectangular. And then we're going to do the size. Now we don't have the exact size of our balsa wood, so we're going to use the smallest they have, which is 1/4 by 3/16. Our balsa wood's 3/32. All right, so a little bit bigger, but this will work. And then we're going to use mild steel. Okay, 1, it's the default. 2, it's not balsa. It doesn't have the same properties as balsa, but it does pretty good in tension and really terrible in compression comparatively. So it works good enough for our balsa. Okay, because we noticed with the balsa, right, it does really well in tension and tends to snap in compression pretty easily. So now I'm going to go have all my things selected, and I'm just going to drag over. Now notice I drag backwards. Now what that does is it grabs anything it crosses over. All right, and so I have all of these selected. I can hit OK, and OK, and OK. And that's so if you want to name them the individual parts, you can. That's kind of hard to see the joints, so we're going to go View, Visual Style, Shaded with Edges, and we can see. Okay. Now we can run a simulation just like this. We don't have to do this next step. I think the next step will help you when you go to build your bridge, so I suggest it. But it does take a little bit of finagling, and you may not want to go to that amount. But there's a couple of things that you can do. We can notch, we can miter, we can trim extend to clean all this up. So I'm going to probably start with trim extend. All right, and how do I know that I want to start with this? It's simply because I played around with it till I got what I wanted, all right? And then I remember it for this. So I'm going to say, all right, I want to trim this part and this part, and I'm going to trim it with this face. And that's going to cut both of those up to here because I want them to sit firmly on this piece here. And then I'm going to hit OK. All right? And it's going to flash, and it's going to look weird, and it's going to look like it's not working, and then it's going to finish, and it's working. All right, and then we can use miter. And miter, you just pick the objects. And it will lay out your miter. It takes a little bit, but it's going to take that shape that you had, and it's going to miter it, all right, and give us nice, neat edges where they join perfectly. And it does take a while, so you have to be patient. All right, and you'll see, right, these are nicely notched into place, and then this is laid in very nice together. And you'll notice that I left these out. Why didn't I pick them? Because I know when I did the before, those get a little weird, and so they work better if you do them individually. Okay, and I know this because I played with it. And again, this is just icing on the cake. It will help you build your truss, put your truss together. Is not a hard requirement. Okay, so now that we've got our truss into place, we can go and do frame analysis. And we're going to create a simulation, and we're going to do static, right? Because everything we do in POE is static. So we're going to hit OK. It's going to think for a second, and then now we have to go and create a constraint or constraints and a force. All right, and you'll notice there's a force already here. That's gravity. It will take into account the weight of its members in its calculations. All right, so we're going to go do a pin connection, which is the same pin connection that I talked about. Don't want that to offset any, so I'll put it there. And you'll notice the constraints. I have a pin here, and then I'm going to do floating. That's a roller connection. All right, they happen to call it floating. It's going to want you to position and use grips to further constrain it. I'm going to right click, say done, because I want it to float left and right, and that's its default. So now I've got two constraints. I'm going to apply a force. I'm going to apply a force right here in the middle. 0 offset. And I don't know what I'm doing wrong, but whenever I do a force, it doesn't give me the option to set the force. So just go up into loads, right click force, edit, put the plane in the other window there, and let's say, you know what, let's do 15 pounds of force. 25, okay? And so now it's going to use gravity, and it's going to apply 25 pounds of force to our beam, okay? And I've got two connections, and so now it's good to go, and now I can simulate. And we'll see that there's an instability in the node, and it's probably not going to be completely valid. That's fine for our purposes, right? We are not trying to get perfect quantifiable data. Okay, we're just going to be able to compare from one to the other. All right, we're not going to be able to say, hey, our bridge is going to hold X. Okay, for one, the material we're simulating with is mild steel, not balsa, so it's never going to match up number-wise. But we can look at it relative to the changes that we made. Okay, so the first thing it comes up with is displacement. So that's how much things are moving. Do note, right? If we look at this from the top view, right, and you can, and it will show you, right? This is our straight truss member, and we can see that our truss is flexing and twisting. So it does a 3D, and that's mainly because we put the force is being applied not in the center of the force is, as it's being applied, is that it's allowing that truss to twist. All right, so it does do 3 dimensions. So please keep, please look at it in all 3 dimensions, and you'll see, right, the parts, and it will show an exaggerated. You'll notice here that because we didn't put much force on it, it is not deflecting displacement. How much is it moving? It's not deflecting very much, 2/1000. Okay, if we go in and we edit this and we give it a lot more force, like let's give it 100. All right, and we'll simulate that. We're going to get more displacement because we're putting more force on it. All right, so now we're getting 10,000s worth of displacement. All right, and you can see this flex. The one that's more important, so that one, displacement, how much is things moving, that's important. But the one that you really want to look at is go down here into normal stresses and do S-axial. Axial. Double click it, right? And just like in West Point Bridge Designer, things that are blue are in compression. Things that are in red are in tension. Okay, so we can see, right, we're getting about 1.2 in compression on these 3 members, and we're getting about 1.2 of tension in these 2 members. All right, and this is it's KSI, which is thousands of pounds per square inch. All right, because again, we're dealing with steel. Right, we would not be holding this with balsa. Okay, so we note, right, that this, and this, right, are undergoing way more stress than this piece. So these probably need to be bulked up in comparison to our horizontal member, right, because it's not experiencing as much stress. All right, so what we can do, we can finish frame analysis. We can go in, and we're gonna change the thickness of these 3. We probably should do these 2 in the middle, but for our purposes, we're gonna do these 3. So as you hover over, it will highlight. And so if you hold down the control key and click, as you hover, and it gets to the one you want, click, control key is being pressed, click. Now I've got all 3 of those selected. I can right click and say edit with frame generator. Now this is the cool part, right? I'm not having to monkey with any changing, each of those parts, right? I just go in here, I'm going to change size, right? I'm going to double this from 3/16 to 3/8, right? So 1 dimension stays the same, the other one gets doubled. And it's just like putting 2 pieces of balsa side by side of the same size. Hit apply. It's going to say, hey, I'm changing frame members, and I'm going to give you a new frame, and we're saying, sure, do it. And it'll have to think for a little bit. Hit X. And then when we look at it, you'll notice that that frame member is now 2 pieces side by side. Now they're together, so you don't see the line in the middle, but you notice that they're thicker. All right, so now I can go back to design, frame analysis, simulate, chug, 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 chug. I'm still looking at axial stress, right? And where before in my, so these 2 are compression, these 3 are in tension. I may have said that backwards, but that's just my mistake, right? So yeah, blue is tension, red is compression. And before, the red was about 1.2 kips, or KSI to begin with. We left that unchanged. But notice that we were at 1.2 before, and now we've basically, because we've doubled it, we have halved the stress in that member, right? Because that force is being spread out over a greater surface area. Okay, so the idea is you want to get all your stresses by designing the thickness of your member, balancing out all of your stresses to the best of your ability, right? Using the things that you have. Okay, and again, if you want to go back and change things, finish frame analysis, and then go to design, right, or right click on it, edit with frame generator. All right, so give that a shot. You don't have to, it's not a requirement that this be in the report. I probably should make it that way, but if you do this, you will have a superior bridge, and if you do it, please put it in your report. Just take some snapshots. If you go to frame analysis and you do the simulation, there is down here where it says report. And you can run the report, and it's going to chug through all the bits, and you can pull out. It'll make you a PDF file, and it'll pull out your. It will pull out your analysis of your frame. Now notice we're getting a little bit cut off, so you probably want to zoom back out. You could redo it. But you can see all your forces in your X's and Y's and so forth and so on. So hopefully this helps. I'll put this on the Google Classroom so you guys can see it. Thanks.